Bismillahirrahmanirrahim. In this video, we'll talk about singularity functions. And singularity functions are just like tools that we use in mechanical. In electrical, the singularity functions behave like the fundamental tools or basic tools. So what is singularity? It means quality of being singular or unique. A basic understanding of singularity function will help us make sense of the response of first order circuit to a sudden application of independent DC voltage or current. So just like we have a step response, when we apply those, if you know the behavior of singularity function, we can easily understand the behavior of a step response function. Singularity functions are also called switching functions, and they serve as a good approximation to the switching signals. And the three most widely used singularity functions in circuit analysis are: first one is the unit step function, then is the unit impulse function, and then is the unit ramp function. Now let's learn what is unit step function. The unit step function is denoted by UT, like here. It is 0 for negative values of t, so 0 for negative values of t, and is 1 for positive values of t, so the value is 1 for positive values of t. So basically these are the 2 points. This is just we use to connect. There is nothing here, or we can't define what is here. You can say that this is 0, somebody will say it is 0.2, somebody will say it is 0.5, somebody can say it is 0.8. So it is kind of undefined. So it is generally drawn like this here. So mathematically we can write ut is equal to 0 for t less than 0 and is 1 for t greater than 0, so 1 for t greater than 0, and it is undefined as t is equal to 0. Now if we shift the changing, it was changing here at t is equal to 0. If we bring it to another point t is equal to, let's say, 2 seconds or 5 seconds or 10 seconds, if the change occurs at here, then we can say that the function has shifted by t0. So in that case we'll write the name of the function will now become ut minus t0, and the values again remains 0 for t less than t0 and 1 for t greater than t0. So this is also called the function has been delayed by t0, it is moved to the right side. And similarly we can advance the function if the change occurs in the negative side of 0. So at t is equal to minus t0, the change is occurring. So now we'll write as ut plus t0. Now don't get confused by these signs. If you put this equal to 0, then we'll have t equal to t0, so that means t equal to t0. And if you put this equal to 0, then t is equal to minus t0, so t will be minus t0. So keeping this in mind, you have to write this sign. Okay, now there is another application of this. Assume that this is the circuit here and it is connected with ground. So when we move the switch to the upper point at any time t is equal to 0, then what will happen? This V0 voltage will suddenly be applied to the circuit. So we can say that the voltage in the circuit is 0 for t less than 0 or t less than t0, and it is this is applied, so it is V0 at t greater than 0 or t greater than t0. Now the same thing can be achieved by just writing ut with v. So v0 ut and replacing all this switch, no need, will give the same function, because we know ut is 0 for t less than 0. So 0 multiplied by v0, it will be 0 for t less than 0, the same value. And it is 1 for t greater than 0, so v0 multiplied by 1 will give v0. So this circuit can be replaced by v0 ut. Now we come to the unit impulse function. You know, impulse is kind of a sudden increase of voltage or sudden application of voltage, and then quickly it diminishes. So this is called impulse signal, represented by delta function, delta t. And basically it is the differential of this. If we take the derivative of this point, so dv dt, now v is just going from 0 to infinity, so dv dt will also become infinity. The unit impulse function delta t is 0 everywhere except t is equal to 0. So it is 0 here, it is 0 here, and it has a value at t is equal to 0, only at t is equal to 0. And this value is, again, it is going to infinity, it is undefined. So we can write that delta t is differential of ut dt, which is 0 for t less than 0, which is 0 for t greater than 0, and at t is equal to 0, it is undefined. Now for all practical purposes, we say that this has no width or very less width and infinite height. So the area is equal to 1, unit area. That is, width multiplied by height is equal to 1. So we sometimes write 1 here instead of infinity, and that is why it is called unit impulse function. So it is customary to write 1, denoting the unit area. And this is just to give you an idea how the three impulse functions can be viewed or can be looked at. At 0, it is, let's say the amplitude is 10, so we write 10 delta t. If the amplitude is minus 4 at point 3, then we write minus 4 delta t minus 3 shifted by 3. And if the amplitude is 5 at minus 2, t is equal to minus 2, then we write 5 delta t plus 2. Okay, the next function is called ramp function or a unit ramp function. So this is as shown here. It is 0 for less than 0, t less than 0, and it is a straight line with slope 1. And this is actually obtained by integrating the unit function ut. So if you integrate, it will gradually keep on increasing. So the ramp function is also denoted by RT. So RT is nothing but the integral of u lambda d lambda or ut dt, and this is equal to t, because u is 1, so t we can also write ut to just show that it is on the positive side. So RT is 0 for t less than 0, t less than 0, RT is 0, and RT is equal to t for t greater than 0, so it is t, equation of a straight line with slope 1. The unit ramp function is 0 for negative values of t and has a unit slope for positive value of t. And we can also shift this function. If we shift it to the right, it will now be known as RT minus T naught. We have shifted it by T naught. And we can also advance it by minus T naught. So it will now be RT plus T naught. And the values in this case, RT minus T naught is 0 for t less than t naught, so 0 from here, and it is t minus t naught for t greater than t0. So this is the straight line. Now its intercept, if you extend it, will be somewhere here at minus t naught. So that is why we following y is equal to mx plus c. This is 1t, 1 is the slope into t, and this is the intercept c, that is minus t naught. And similarly we can write this one. Okay, now let's do this example. We have to express the voltage pulse shown here in terms of unit step function, and also calculate its derivative and sketch it. So the first part, we can say that this is a unit step function with value t from here to here. This is now going all the way. So 10 u t minus 2, because it's starting at 2 and going all the way to infinity. But in our question it is terminating or finishing at 5, t is equal to 5, and therefore we have to subtract whatever amount is here at this point. So let's see how it is done. We draw another curve toward the negative direction of the same unit impulse of same magnitude in the negative side. So we'll write it now minus 10 u t minus 5, because it is starting at t is equal to 5. And now when you add these two, you get this curve. So mathematically we can write that Vt of this curve is 10 ut minus 2, so 10 ut minus 2 plus minus 10 ut minus 5. So plus minus 10 ut minus 5, or actually minus 10 ut minus 5. So this is the first part. Now we go to the second part. We're taking derivative. We know the derivative of ut is lambda. Delta t minus 2, and this will be minus 10 delta t minus 5. And so we can very easily plot this, that at t is equal to 2 we will have a 10 delta t minus 2 value here, and we'll have a minus 10 delta t minus 5 value here. So this is the derivative plot. Now let's do the practice problem. Here also we have to express this pulse, current pulse, in terms of unit step function, and then we have to integrate and sketch it. So for ease of understanding, I'll break this into two parts separately. This is saying one gate pulse, and this is another gate pulse. And now we can easily draw, as in the previous slide we did. We draw 10 ut for this part, 10 ut, and then we have to terminate this at 2, so we draw another one in the negative direction, so negative 10 u t minus 2. So these two will get cancelled, so we'll get this curve from here. Similarly, this is going in the negative direction, so we need to draw a negative unit function here and then terminate that. So let's do that. So we drew a negative unit step function, negative 10 u t minus 2, and now we got to finish it at 4, so we have to bring it up or finish it up, so we got to have a positive function, so that can cancel the negative function. So it will be like this. So we have a positive at this point. So this will also now give the curve here. And mathematically now we can write this one will be 10 ut, so 10 ut minus 10 ut minus 2 plus this function, and then minus 10 ut minus 2 plus 10 ut minus 4, and since these two terms are same, so we'll add them. So it will be 10 ut minus 2 ut minus 2 plus t minus 4. We have taken 10 common from all of these. Okay, now to find the integral, this was the function that we had. So for ease, again we are just multiplying everything by 2, so we're getting this function. Now we take the integral of all the terms individually. And we'll apply this formula RT for the ramp function. RT is integral of u d lambda. So we can write all these in terms of RT or the ramp function. So 10 ut will now become 10 RT. 20 ut minus 2 will become 20 RT minus 2, and this will become 10 RT minus 4. We'll apply another formula of shifting, that if RT is shifted by T naught, then its value will be T minus T naught. If it is not shifted, if it is just T naught, RT, then this value will be equal to T. So in the first case there is no shifting, so RT will become T. Here it is shifting, so we'll write it 20 T minus 2 from here, T minus T naught, and this will be 10 T minus 4. And for our ease, I'm just writing this time when the changes is valid or changes is occurring. So we were here, multiply by 20 and 10, we get this equation. So now we have these three equations at three different time frames. So we can plot them directly, and this will be the plot. First of all, we're plotting 10t. This is valid from t greater than 0. Then we plot minus 20t plus 40. So minus 20t plus 40, this is the intercept 40, and this is starting at t greater than 0. And then we have 10t minus 40, so 10t minus 40 starting at t greater than 4. Now if you add these terms, this and this, we'll get a graph which will look like this. Now this is slightly difficult for many students to understand how we are adding this and how we are adding all three. So I would prefer to write it in a simplified manner, and that is, I'll write that integral t is equal to 10t for t between 0 and 2. So that is this range. For t between 0 and 2, this will be 10t. Then between 2 and 4, we have to add whatever was coming. That means this curve is still 10t, and we are going to add with this at this point. So 10t and minus 20t plus 40, and this will simplify to minus 10t plus 40, and the range is from 2 to 4, 2 to 4. And then for this range, which is greater than t, we have 10t, we also have this curve, and we also have this curve. That means addition of all three, which is becoming 0, because 10t and plus 10t, 20t minus 20t will be 0, plus 40 and minus 40 will be 0. So the net answer is 0. So for t greater than 0, the function value will be 0. And now we can plot these three. So this is 10t line, but it will finish at t is equal to 0, and because the another line will start, which is minus 10t plus 40, so it will become like this, 10t up to this point, and then minus 10t plus 40, and after 4 the value is 0, so we don't need to write that value 0 here. So this is easier to understand and plot. And just for your information, if you see this original signal, basically these two values are important, this 10 here and minus 10 here. These lines are meaningless actually. This is just for the purpose of beautification we add these lines. Now if we integrate 10, it will give 10t, so we can say it is 10t, and if you integrate minus 10t, it will give minus 10t, so this is minus 10t, and if you extend this, the slope will be plus 40. So this way you can verify that your result is correct. So I hope this gives you an understanding as to how to solve this type of a problem. Thank you.